Alright, ladies and gentlemen, we've made it to the last page. And here we're asked to go and write the half reaction for the reduction that occurs. First step, let's assign oxidation numbers to all the species in the reaction. We already have oxidation numbers for the chromium ion and the zinc ion. So we just have to assign the oxidation numbers for the zinc atom. It's a lone element, so it will be 0. And the chromium atom, again a lone element, so it'll be 0. Now when we look and see what has changed, the zinc has gone from 0 to 2. That's an increase in oxidation number, so it's oxidized. While the chromium has gone from 3 to 0. That's a reduction because the oxidation number is going down. So to write the half reaction for reduction, we're going to write the chromium and its symbol separated by an arrow. We see that the chromium has started out as +3 and it has ended up to 0. Now to balance our half reaction, we have to add electrons. Remember, the number of electrons added is always equal to the difference in the oxidation numbers. So in our case, it's going to be +3. So we're going to add 3 electrons to the more positive side, or the reactant side. Now this makes great sense because we remember that the gain of electrons is reduction. In a chemical reaction, everything gained is found on the reactant side. Now to write the oxidation half reaction, we're going to focus on zinc. So here we're going to write the zinc symbols separated by an arrow. Now here, zinc is going from 0 to +2. Now again, we're going to have to go and add in our electrons, but this time the electrons will be on the product side. There'll be 2 electrons. The loss of electrons is oxidation. Lastly, it tells us to balance the reaction with the smallest whole number coefficients. Now, looking at the reaction, it appears to be balanced because there is 1 zinc on each side and 1 chromium on each side. But when we look at the mathematical expression, it is not true because 0 plus 3, or 3, does not equal 2 plus 0, 2. So what we're going to have to do is make sure that the number of electrons gained by the chromium is exactly equal to the number of electrons lost by the zinc. To do this, we have to make sure that we multiply each half reaction so that we can have the number of electrons be the least common multiple. The least common multiple between 3 and 2 is 6. So what we're going to do is we're going to multiply the entire top reaction by 2. So 3 times 2 is 6. And then we'll have a coefficient of 2, so each species gets a 2 here. And we'll multiply the bottom reaction by 3. So everything will get a 3. Now, in order to balance the reaction, we'll simply add the 2 half reactions together, noticing that we can go and eliminate the electrons because we have 6 electrons on the reactant side and 6 electrons here on the product side. Using the spaces provided, we see that the zinc atoms always have a coefficient of 3, and the chromiums have a coefficient of 2. We check our work by checking the mathematical expression. 3 times 0 is 0, plus 2 times 3 is +6, equals 3 times 2 +6. So this is balanced. The next question asks which species loses electrons and which species gains electrons. Well, remember that the loss of electrons is oxidation, and the item oxidized has an increase in oxidation number. So in this case, we're going to have zinc atom, and it's going to go and lose electrons because it is oxidized. And then the chromium ion is going to gain electrons because it is reduced. The next question asks, which half reaction occurs at the cathode? We can recall that we remember that there's a red cat. So the cathode is where reduction occurs. Recall that chromium is being reduced. So chromium would be our cathode here. The final question asks, what happens to the number of protons a zinc atom changes to a zinc ion? Well, recall that proteins are the identifying particle of an atom, and notice that the identity of the particle, the zinc identity, is not changed. So here we're going to say that the number of protons is constant. Now this is really important because if the number of protons were changing, we know that protons are located in the nucleus. And if protons were changing, the nucleus would be changing, and we would have a nuclear reaction. In chemical reactions, we always have the same kind and number of atoms on the reactant side as the product side. So in chemical reactions, protons never change.